It's okay?
Yeah. Thank you very much, Yaniv. And it's a pleasure for me to be here at Tel Aviv University and in Israel. It's been a great conference so far, and it's really been an honor to be involved with Tel Aviv University. This is joint work, as yet incomplete, with several people, including Tudor Dimitris and Michael Ofulgone at University of Maryland and Aditya Prakash at the Virginia Tech. So the results I'm going to present are based on analysis of 2 years of data conducted as 2 studies, but I'll talk about only one today. This is the data collected by Symantec and made available to us under fairly controlled circumstances. All the data that Symantec collects and made available for the study was collected on an opt-in basis. So in other words, if you use Norton antivirus, you have an option to check a box when you sign up for it, which allows Symantec to collect anonymized data about you and make it available for research purposes. So I'd like to start by thanking Symantec, without whom this research would not have been possible. We did 2 studies, and even though I have my slides containing both, I'm largely going to talk about the second. One was a human vulnerability study. What are the behaviors of humans on computers that make them vulnerable to different types of attacks? Number one. And the second part, on the basis of that, was what can we quantify somehow on the basis of the data what we can say about the cyber vulnerability of different countries. But I'd like to sort of start by a few caveats. First, our data is based on information about individual subscribers, not enterprises, not military or professional organizations involved in security. So it's only applicable to consumer data. Let me make that clear when I start. I'm going to just skip this and say a little bit about the worldwide intelligence network environment of Symantec. This contains a number of data about reputation of different types of binaries sitting on host machines. So if you're running a machine in your office or your laptop and you use Norton antivirus and you've opted in, you're basically contributing information about your data and your computer to the system. So this includes data on all binaries, including ones classified as malicious or benign, includes a bunch of information about them, as well as a lot of antivirus telemetry. Things like when was the malware detected, what type of threat label was assigned to it, etc., etc. Norton antivirus shoots for very, very high true positive rates and very low false positive rates. So we have pretty high confidence on the accuracy. I'm going to sort of show you the summary of what we found. We looked at a number of independent variables. All of these statistical results have p-values significantly less than 0.01 in general. And what you see here is that any check mark here shows a high confidence that different categories of users of machines correlate the number of malicious binaries on your machine with various activities. So for example, if you tend to use low-frequency binaries, these are binaries which are pretty rare. You're more likely to be infected across the board. If you use binaries that are unique, that are very, very rarely seen, you're much more likely to be infected. If you use binaries that are downloaded, example by drive-by downloads or downloaded from the web explicitly, much more likely to be infected. If you connect from a lot of ISPs, we didn't find compelling statistical evidence that you're much more likely to be infected and you're not correlated to the number of attacks. I'm going to just skip over some of these, but I wanted to just show this chart. This chart shows you the 5 categories of people. We classified users of machines into 5 categories: gamers, software developers, professionals. Professionals are people who use, for example, spreadsheets, people who work in companies, Microsoft project, those kinds of things, and others, and everybody. And these show you on the y-axis the average number of attacks or pieces of malware on their machines, and on the y-axis it shows you the decile category. Just think of this as if you're in the 9th decile, you're in the top 10% in terms of the number of users. The number of binaries. So how many? Can you guess which of these? Y-axis again shows you the number of attacks. Can you guess which category belongs to whom? Who's susceptible? Who's the blue line in particular? Who's susceptible to the most number of attacks? Okay, so I hit that. So it turns out the blue is actually software developers, even after discounting for the fact that software developers, we thought gamers would be it too, till we saw that the data showed us something else. So even after we discounted for the fact that software developers are actually compiling code and therefore generating binaries on their machine, which should not be counted, we discounted for that, we still found software developers at the top of the heap. So if you're a computer scientist in this audience, what this suggests is please be careful. What you use. I know everybody has project deadlines. We tend to use open source software. We tend to go to SourceForge and download stuff. Watch it. I'm going to skip forward, and these slides are available and talk about our, oops. Okay. So our country vulnerability study looked at 2 years of data. I'm going to call them 2010 and 2011. 24 months, but it's not quite 2010 and 11 from January 2010 to December 2011. It actually started, I think, a little later. But it goes for 2 years. And we have about 4 million machines monitored in each of those 2 years. We looked at over 20 billion malware reports. And we had data on pretty much most countries in the world. We got rid of any countries, not got rid of countries, but got rid of the data about countries in those cases where we had less than 500 machines in a given year. What I can say is in 2010, we had only a handful of countries, 3 or 4, for which we had less than 1,000 machines. In 2011, every country we had more than 1,000 machines being monitored. So we wanted enough data. We looked at 2 dependent variables we're trying to understand. One, the percentage of machines in a country that are infected with at least one piece of malware during this period. And 2, the number of infections per machine in any given country. Okay, so in other words, if I pick Israel or China, what's the number on average of infections on that machine for that country during this period? These were the 2 dependent variables we were trying to understand. So the first, let me start with, well, there's some good news, and I'll say that up front. The first piece of good news is that we found that approximately half the machines actually were infection-free. It was a big surprise to us. We'd expected that number to be much less than 50%. So for the 2 years, we had an almost dead heat in both years for which countries were the most vulnerable. Any guesses on the most vulnerable countries? Russia, China, United States, Brazil. Okay, so Estonia. Okay, so here's more or less the list. So I want to say that those who said China are not way off. Okay, I'm sort of adjusting these numbers just a little bit as we are finishing the study. So right now our survey is about 200 pages long. I'm wrapping it up. Those of you who've written a book know that the last 10% takes 90% of the time. So what we are finding is that depending on whether you look at 2010 or 2011, India and South Korea are actually topping the charts in terms of being the worst, okay? According to both measures. So in other words, the worst affected in both measures. Russia is not looking that great either. And China is, just out of this top 5, okay? Or worst 5, as the case might be. So again, when I say a country is doing badly, it's not meant to reflect badly on the country. It's just, what's happening. What about the best? Who are the least vulnerable? Any takers? Sorry? Israel? Switzerland? North Korea? Sorry? Okay, so North Korea, I have no data, okay? So I can't say, and let me say one thing I forgot to say earlier. We have a total, after I got rid of the data on countries for which we didn't have enough machines being monitored, I was left with about 44 countries. Those include most of the major developed economies and OECD countries, most of the major developing economies, etc. So, and those that are sort of on the, borderline of being sort of in the Brazil, Russia, India, China group. So the countries with the lowest rate of attacks, somebody said Switzerland, somewhere around there, yeah. Good shape there, good guess, or good knowledge. But the Scandinavian countries and Switzerland top this list. Germany is actually just slightly outside this list, still in the top 7 or 8. The United States, which I also heard people mention, UK, Australia are all clustered between around 11, 12, 13, that range. It varies a little bit by the 2 years and the dependent variable I'm measuring by. Percentage of machines that are infected or the average number of pieces of malware on the machine. So, you know, it's a close call, but that gives you a quick idea of what's going on, at least in terms of the best and the worst. In our report, I have an appendix consisting of 2-3 pages on every single country, showing the basic statistics for that country. Yesterday, one of the speakers at the main conference, the gentleman from Gartner, bemoaned the fact that nobody had a map that kind of looked like this. I don't have the whole map. As you can see, there's a lot of white space in this map, representing large parts of the world where I don't have data. But you can see that this is a sort of crude, and you know, I'm a computer scientist, so I don't do good art. And so these graphics don't look as good as I would like it to look. But it sort of gives you a quick picture of what the world looks like in terms of cyber vulnerability of different countries. This is Europe, and again, you know, so average number of attacks per host. See, this y-axis starts at 0.5, okay? So this is telling you that approximately half the machines have 0 attacks. That's the good news. This is a CDF showing us the percentage of machines. So for example, you know, most machines have less than 50 attacks on them. And I want to say a few things. The average number of attacks per host is growing in countries. So each of the dots in this country, in this map, represents a particular country. The x-axis shows the percentage of attacked hosts. Y-axis shows the average number of attacks per host. Not surprisingly, you can see this number increasing. If a country has lots of compromised hosts, you expect users in that country to be perhaps less careful or more vulnerable for whatever reason. And so you expect to see this. That's not surprising. By the way, I just have a smattering of pictures here. I have lots of graphs like this for every variable in question and each of the 2 years of data. Okay, here's something really interesting. And if there's somebody from South Korea, I'd love to hear their explanation for this. I don't have a good explanation myself. But this shows you, we sort of tracked also periodic monthly rates. And for some strange reason, both in 2010 and 2011, South Korea experienced a significant increase in the number of attacks during that winter time frame, you know, December, January, February, March, April. Somebody knows why? Okay. Okay, so good point. I could not, you know, the problem with the data is I have basically 2 time slices of these periods. And so I can't say anything with certainty about why from a statistical perspective. So that's why I'm not trying to guess, but that was one of our guesses as well. Piracy. So, you know, so a lot of software vendors tell us that piracy rates in countries are correlated with increased number of attacks or vulnerability of those countries. And this picture shows you that that's the case. I've highlighted a few countries here. And this is 2011 data when South Korea had more attacks than anyone else. So the y-axis, average number of attacks, piracy rate on the x-axis. You can see if I was to fit a line to it, it would be an increasing line for sure. But does this mean piracy is responsible as many people have claimed? Well, next slide here shows that it perhaps might be GDP instead. So for instance, if I plot GDP of countries on the x-axis and the average number of attacks per host, you can see that this is a decreasing curve. As GDP goes up, you're seeing lower attack rates per host in that country. There are a few exceptions. You know, South Korea has a pretty, is just an outlier here. Again, North Korea is, you know, my plausible explanation, but I can't sort of pin it on them, all right? So I will, you know, leave it with that. So again here, what this suggests is that perhaps GDP is the factor that's playing a role, and it's low GDP that's driving perhaps increased software piracy, which in turn is driving increased vulnerability. But it could also be argued that increased software piracy is being driven by increased unreasonable costs of the true software, the genuine software, being unreasonably unaffordable in the markets in which it's being sold. So I think, I can't really say the software developers are right or wrong. They're correct that there's a correlation. They're not correct, as far as I can tell, that there's a causation. I don't see that in the data that I've seen. Downloaded binaries are correlated with increased risk. I can easily fit a curve here. But there are outliers like China. So China has a pretty high percentage of downloaded binaries that we saw per machine, but the number of attacks is still high, but nowhere near as high as we thought it would be. So even though I can fit a curve to this and show increase in risk to a country based on increased number of downloaded binaries, there are significant exceptions to the rule, which you would expect. By the way, I'm showing these pictures instead of harassing you with statistics, showing R-squared values, p-values, etc. Everything statistically validated. There are multiple various kinds of regression models we fitted, etc. So I know I'm running out of time, so I will basically, I've got a lot more, but I would say that when I actually do a Poisson regression model, coming back to software piracy, I'm just going to show you one geeky slide, okay, which is this one. When I come back to software piracy and build a multivariate regression model, we tried all kinds of models, and the best fits we got were with multivariate Poisson regression models. What we see is that the significant variables are actually GDP and the percentage of downloaded binaries as opposed to piracy, which gives me some confidence in saying it's probably not piracy. That's the factor in question here. So I'll conclude with that. We also get decent lift, etc. I'll conclude with that. We're wrapping up the study. We hope to put it out early next year once it sort of makes its way through the review process. So thank you very much.
One question, Professor Subrahmanian. Can I ask?
Please.
The statistics that you presented is based on incidents that were detected by anti-malware system, or what about the stuff that was not detected?
So actually, very good question. So this is. So let me start with many flaws in the study, okay? So our paper includes that, but as I had 12 minutes, I didn't go through all the flaws. So first, as you correctly point out, we are monitoring machines on which Semantic antivirus is actually installed. Norton antivirus is detecting these malware, so when I count an infection, it's actually a deflected attack, and the intention is that the attack, so in fact, I would expect that in the population of machines that are not protected by a comparable software, not necessarily Norton antivirus, but that of perhaps a competing vendor, we would expect that actually the true infection rates might actually be a little higher. But I have no way of monitoring machines that I don't have something running on right now. So the best I can do is to use this as a proxy for that. So that's what we did. But you're absolutely right that that's a flaw in the study. I fully agree. There are a number of other flaws I could also go over. But this is sort of the best we were able to do. But absolutely fair question. Yeah.
Great. Thank you.
Thanks.
I would like to thank the professor. I think it was incredible, and you can invent a kind of watch of all the global situation according to such a very rich database.